And good morning to everyone. So our today's lead code question is 396, that is rotate function. So in this question we are given an integer array nums whose length is n, and we have to set that we have to assume an array of k which is obtained by rotating the nums length by k positions clockwise, right? And we define the rotation function f on the nums array as follows, that f of k is equal to 0 into 0th element plus 1 into first element and up to last element, that is n minus 1 into last element, right? So this is a rotation function, and what we have to do is we have to return the maximum value of f of 0 means without any rotation, with one rotation, and up to n minus 1 rotation. So we have to try out all the rotations and find the value of the rotation function, and we have to return the maximum value of these rotation functions. It is also given that the test cases are generated so that the answer fits in a 32-bit integer, means the answer is an integer only, right? So let's see examples to get the question more clearly. So in the first example we are given the nums array 4 3 2 6. So first we find f of 0 means without any rotation, that is 0 into 4 plus 1 into 3 plus 2 into 2 plus 3 into 6. So which is 0 plus 3 plus 4 plus 18. So this is 25, right? Then we do one rotation. So after one rotation the array will become 6 4 3 2, and then we find f of 1. So f of 1 is 16. Then again we do one rotation, the array will become 6 2 6 4 3. Then we find f of 2. F of 2 is 23. Then again we do one rotation and the array will become 3 2 6 and 4, and then we find f of 3 which is 26. If we do rotation one more times, we get the initial array only, right? We get the initial array. So we have done all the four different type of rotations. So the maximum value in the first one we get 25, then we get 16, then 23, and then 26. So the maximum value is 26. So we have written 26 as the answer. Next we have in the next example we have only one element. So 0 into whatever the element, it will always give us the answer as 0. That's why we have written the answer as 0, right? So let's see the constraints. So n, which is the nums dot length, basically the number of elements in the nums array, n can be up to 10 ki power 5, right? So we have to think of some solution of either big of n or n log n. N square will be giving us time limit exceed, right? So n square can't be used, and each element in the array can be from minus 100 to 100, right? So let's see the approach part. So first we will see the brute force approach, right? So what we have to do is we have to rotate the array every time, and then we compute the rotation function value, right? F of k. So and then we compare this f of k with the previous result and store the maximum every time. But if the array has n elements, the total rotation will be n only, right? N rotation. And to compute the rotation function value, what is the time complexity? So we have to go to each element. So if n elements are there, then to compute the value of the rotation function, it will take big of n time. So what is the total time? So after every rotation we have to compute the value of the function. So total time is big of n into n, where n is the total rotation and this n is for computing the value of the function. So the time complexity of this brute force approach is big of n square, and as we know n is equal to 10 ki power 5. So big of n square will be 10 ki power 10. So it will give us time limit exceed, right? So we have to optimize the approach. So let's see the optimized approach. So now what was the mistake that we were doing in the brute force approach? The mistake was that we were rotating the array every time. So instead of rotating the array every time, what we do is we observe a relation. We observe a relation between the consecutive value of the function. So first let's see what will be f of 0. F of 0 is 0 into a of 0 plus 1 into a of 1 plus 2 into a of 2 and so on. So this is the value of f of 0. Then if you see what will be the value of f of 1. F of 1 is last element will come to the first index, that is 0 into a of n minus 1, 1 into a of 0, 2 into a of 1 and so on, right? So if we simplify this function, and write 0 into a of 0 plus 1 into a of 1 plus 2 into a of 2 plus n minus 2 into a of n minus 2, and then see we have taken one value from here, so we have added a0 a1 a of n minus 2. So this value up to here is f of 1, right? We just have write it in a different way, right? Then what we have done is we have added a of n minus 1, n into a of n minus 1 and subtracted n into a of minus 1, so overall it is 0, right? But if you see this function, see what we want. If we add n minus, if we take n minus 1 into a of n minus 1, n minus 1 into a of n minus 1 from here and write it over there, and we add the one a of n minus 1 left here, we add that here, a of n minus 1, right? So see what we'll get. We'll get, see, 0 into a of 0, this function, plus a of n minus 1. So we basically have splitted the a of n minus 1 terms. We have taken n minus 1 n minus 1 times here and one time here, right? So basically if you see this term is f of 0, and this term is the sum of all the elements. All the elements. So if you see f of 1 is equal to f of 0 plus sum of all the elements minus n times the last element, right? So this is the relation between f1 and f0. So if we generalize this term, we get f of k is equal to f of k minus 1, f of k is equal to f of k minus 1 plus sum of the array minus n into nums of n minus k, right? So this is the generalized term. So now instead of rotating the array every time and finding the rotation function, we now use this formula to calculate all the values of f, right? So earlier, what was the time complexity? Earlier the time complexity was big of n square, so now that will be decreased from big of n square to big of n, right? So what will be our steps? So what we'll do is, first of all, we'll find the sum of the array, which is the total sum of all the elements, and then we find f of 0, right, which is summation of all the elements I into nums of I, right? And I will iterate from 0 to n. So we find sum and f of 0. Now we use f of 0 to calculate f of 1, right? F of 1 is basically f of 0 plus sum minus n into nums of I minus k is I think 0. This is f of 1. Then we use f of 1 to calculate f of 2. Then using f of 2 we calculate f of 3, and so on we calculate all the values. So what we do is we will iterate k from 1 to n minus 1 and then find all the values of f of k. So basically new f is equal to old f plus sum minus n into nums of n minus k. So this is what we will be using, and every time after calculating new f we'll update our maximum answer, right? So this is a approach. So let's try to understand this approach with the help of an example. So we have taken the array 4 3 2 6. So basically first we compute the sum and f of 0. So sum is 4 plus 3 plus 2 plus 6. So sum is 15. Then we compute f of 0. F of 0 is basically 0 into 4 plus 1 into 3 plus 2 into 2 plus 3 into 6, which is 25. So our initial answer is 25, right? We get our initial answer. Now using f of 0 and the sum we have calculated, we compute f of 1. So f of 1 is equal to f of 0 plus sum minus n into nums of n minus 1, which is f of 0 is 25, sum is 15, n value is 4, and nums of n minus 1 is 6. So on solving this, we get f of 1 as 16. We get f of 1 as 16. Earlier our answer was 25. So now answer is equal to maximum of previous answer comma current answer. So answer is still 25, right? Then using f of 1, we calculate f of 2. So f of 2 is equal to f of 1 plus sum minus n into nums minus 2. So f of 1 is 16, sum is 15, and nums of n minus 2 is 2. So on solving this we get 23, and again we compare it with the answer value. So again still the answer is 25. Now using f of 2, which is 23, we compute f of 3. So f of 3 is basically f of 2 plus sum minus nums of n minus 3, right? So we get 26. So now earlier our answer is 25, current answer is 26. So which one is maximum? Current answer is maximum, right? So we have calculated all the values of f of f. So now we return the maximum answer, which is 26. So this way we have solved the question in big of n approach, right? So let's move to the code part. So in the code part we have taken the size of the array, which is n. Then we have taken two variables, sum and f. So f, basically first we calculate f of 0. So using this loop we have calculated the sum of all the elements, and then we have calculated the function f, which is I into nums of I, means sum of all the elements, right? Sum of all the elements of I into nums of I, where n is nums, right? And then we have, now we have sum and we have f of 0. So now we use f of 0 to calculate f of 1, f of 1 to calculate f of 2, and so on. So using this function, this new f is equal to old f plus sum minus n into nums of n minus k. We use this formula to calculate the new f, and then we compare this new f with the previous answer and take the maximum value and store in the answer. So after finding all the values of f, we return the answer, right? So I hope I am able to explain you both the approaches properly. So if you like the solution, please make sure to like, share and subscribe the channel. Thank you.